explain the ionic equation. The first example, copper nitrate in the aqueous state plus sodium hydroxide in the aqueous state gives copper hydroxide, and the product here is in the solid state, and sodium nitrate, and the product here is in the aqueous state. Ionic equation, actually it's a matter of states of matter, changing states of matter. So the reactants here, copper nitrate and sodium hydroxide in the aqueous state. Then the product, one of them in the solid state and the second in the aqueous state. So in order to get the ionic equation, we have to know which really of the radicals that react actually in the reaction. So if the states change from the reactant to the product, that means the reaction happens. But if the state of the radicals, positive or negative, will be the same, that means that the state doesn't change. That means this radical didn't react or enter in the reaction. So in order to get or to know this ionic equation, we have to know that the radical will take the same state of the matter between two brackets, which here is aqueous. So the copper positive will be in the aqueous state, and also the negative ion will be in the aqueous state. In the product, let's see what happened. The copper here as a cation changed into solid. So here actually the first ionic radical has been composed, that the copper has been changed from the aqueous state to the solid state. What about nitrate radical? Nitrate is in the aqueous state. What happened here in the product? Is it changed or the same? It is the same. So this radical actually didn't enter in the reaction. It in the reactant in the aqueous state, and in the product also in the aqueous state. Let's see the sodium. As I told you, the aqueous state for the positive and the negative. So the aqueous state here for the sodium radical, positive, it will be aqueous. In the product, also aqueous. So it doesn't enter in the reaction. So we dismiss it. The OH is a radical, negative, in the reactants in the aqueous state, but in the product it changed into solid state. So that means it changed the reaction. So we're going to dismiss the radicals same state in the reactants and the products. The nitrate here is in the aqueous state and the product in the aqueous state, so we're going to dismiss it. The sodium here in the aqueous state, also in the product in the aqueous state. Then let's write what will be left. The copper in the positive state, which is copper positive, and in the aqueous state. So we're going to write it. Plus the OH, how many in the balance? We're going to write the balance the same. 2OH negative, the radical is a negative, in the aqueous state, gives the copper hydroxide will be written as a solid state. This is the final ionic equation for this reaction. Let's get another example. Zinc in the solid state plus copper sulfate in the aqueous state. The zinc is more reactive than copper, so it will replace it. Zinc sulfate in the aqueous state plus copper in the solid state. Now, in order to get the ionic, we're going to dismiss the same state. The zinc started at solid state, ended at aqueous, so we don't dismiss it. The copper starts at aqueous state, ends at solid state, so it also enters the reaction. Sulfate in the aqueous state and in the product also in the aqueous state, so we can dismiss it. So the ionic equation after the similar has been from the reactants in the similar state aqueous and the product sulfate aqueous in the product, we're going to write the left will be the ionic, which is zinc in the in the solid state plus copper. The ion of positive copper is 2 positive, and also it is in the aqueous state. We're going to write it. Gives the zinc here, it is a radical carrying 2 positives. Carrying 2 positive, the oxidation number is 2 positive, and it is in the aqueous state, plus copper, which is in the solid. This is the final ionic equation. Actually, the reactants, radicals, changed in the product, this another state. For the other example, lead nitrate in the aqueous state, potassium iodide also in the aqueous state. When they react with each other, they give potassium nitrate in the aqueous state and lead iodide in the solid state. Now we're going to do the same. We're going to, at the same state, we're going to dismiss the same state. How we know it? The lead is carrying 2 positive in the aqueous state. Let's see here, where is it in the product? Here, but it is carrying the solid state, so it really react in the reaction. Let's go to the other radical, nitrate NO3. It is in the aqueous state in the reactants. What about the products? Yes, it is aqueous, so we don't need it. So if they are in the same state, that means they will not enter in the ionic equation. They didn't react. They react as an aqueous and product as an aqueous. Let's move to the potassium radical. Potassium positive 1. It's in the aqueous state. And here in the aqueous state also, so it didn't react. So we're going to dismiss it. What about the iodine radical? Negative in the aqueous state in the reactants, but in the product will be the solid state. So we're going to dismiss similar states in the reactants with the products, and finally we're going to write the ionic, which is left, the lead carrying 2 positive. We know it here from the chemical compound. So it's 2 positive in the aqueous state, plus the 2 of the balance, iodine, it is a radical negative 1, aqueous state, gives the lead iodide, which in the solid state. And this is final, the ionic equation. Silver nitrate in the aqueous state plus sodium chloride in the aqueous state gives sodium nitrate in the aqueous state and silver chloride in the solid state. Now we're going to compare the silver ion positive. The state of it is aqueous. Where here in the product? Here the silver, but it is not in the aqueous, it is in the solid. So it will react in the reaction, and it is considered as one of the radicals that will going to be in the ionic equation. What about nitrate? NO3, it's in the aqueous state. Also here in the product is in the aqueous state, so it didn't react. It is the same state. We dismiss it. Sodium in the aqueous state in the reactants. Also in the product, the sodium in the aqueous state, so we dismiss it. And now we're going to write what is left. After we dismiss the similar states from the reactants and the product, we're going to write the final, which is left to the ionic equation, silver positive in the aqueous state plus chlorine negative left in the aqueous state also will give the silver chloride in the solid state. Barium nitrate in the aqueous state plus copper sulfate in the aqueous state. They give copper nitrate in the aqueous state and barium sulfate. The same, barium 2 in the aqueous state, positive 2. Here also positive 2, but it's in the solid. So actually, it's enter the reaction because the state here aqueous in the reactants and it changed into solid in the product. Let's see nitrate. Nitrate in the aqueous state in the reactants. Nitrate in the product also in the aqueous state. So it didn't react or enter the reaction in this reaction. So we're going to dismiss it. Copper, 2 positive because sulfate is 2 positive. So all of them will go to dismiss with each other. So copper here, oxidation number is 2 positive in the aqueous state. Here copper also in the aqueous state. So we're going to dismiss the copper. Sulfate in the aqueous state, 2 negative. Here sulfate SO4 in the solid state. So actually it changed the sulfate from aqueous in the reactant to the solid in the product. So what we're going to dismiss is the nitrate and the copper. And then the final will be barium, 2 positive in the aqueous state, plus sulfate, 2 negative in the aqueous state, gives barium sulfate in the solid state. The first question says, when sodium aqueous is added to aqueous iron 3 chloride, a solid product is formed. Name the type of reaction where a solid is formed between two solutions. We know that the type of reactions when a solid is formed is called precipitation. State the color of this product. Of course, we know that iron 3 oxide, when it is added to sodium hydroxide, this is the iron 3 hydroxide salt, and the color will be a red-brown precipitate solid. Name this solid. So the solid here is iron 3 hydroxide. Write the ionic equation for the reaction, include states symbols. So as we took the sodium hydroxide aqueous plus the iron chloride aqueous. So we're going to dismiss similar states. Sodium aqueous, let's write the products first. Sodium chloride, which is aqueous, plus iron hydroxide, which is in the solid state, and the color is reddish brown or red brown. So, and the valency is 3, we're going to write it. So here is solid, and here the sodium chloride is in the aqueous state. So now we're going to dismiss the sodium in the aqueous state. Here also the sodium in the aqueous state. Hydroxide in the aqueous state, hydroxide here in the solid, so we don't dismiss it. It's one of the radicals that enter the reaction. Iron 3 in the aqueous state, iron 3 here in the solid state, so we don't dismiss it. Chlorine in the aqueous state, and also chlorine here is in the aqueous state. So we're going to dismiss also the chlorine, and the final will be the iron 3 positive plus the 3OH negative OH gives iron hydroxide solid, which is the ionic equation. When aqueous silver nitrate is added to aqueous potassium chloride, a precipitate is formed. State the color of the precipitate formed. Of course, silver nitrate for group 7 for chloride ions and bromide and iodide. It gives with chloride white precipitate. Name the precipitate. We call it silver chloride. Now write the ionic. So the equation here, we're going silver nitrate plus potassium chloride in the aqueous state. It will give double decomposition, potassium nitrate, which is in the aqueous state, okay, and plus silver chloride, which is in the solid white precipitate. And we write solid. Let's dismiss the similar states. Silver in the aqueous, silver in the solid, no, we couldn't dismiss it. Nitrate in the aqueous, in the product nitrate also in the aqueous, so we can dismiss it, cancel each other. Potassium in the aqueous state, potassium in the aqueous state, so it's the same state, we cancel each other. Chlorine in the aqueous state, here chlorine in the solid state. So what is left will be actually the ionic equation, which silver plus chlorine gives silver chloride.